Hi, I'm Ralph Elizardo. I am making this video to help you understand about the types of discontinuity in calculus and to make basic calculus even more basic. Our objectives for today are to identify the different types of discontinuity, to identify the discontinuity using graphs, to identify the discontinuity using functions. A discontinuity is a point at which a function is discontinuous or undefined. These are the three types of discontinuity: removable or whole, and essential. There are two types of essential: the jump and infinite. This is an example of a graph of a removable or whole discontinuity. As you can see, there's a hole on the graph and there's a point below or above the graph. This is an example of a jump essential discontinuity. The graph shows almost like a removable discontinuity, except it's not a point but another graph. Infinite essential. The graph of an infinite essential is an asymptote and it is discontinuous at the dotted lines. Here are the steps to identify the continuity of a function. First is to solve for f of c. Second is to identify the limit of f of x as x approaches c. The last is to check if f of c is equal to the limit of f of x as x approaches c. These are other examples using functions. Here's an example of a piecewise function with a removable discontinuity. The first part of the piecewise function is x plus 3 and x is not equal to 4. The second part is 5 and x is equal to 4. Is the function continuous at x is equal to 4? We will use the steps to identify the continuity of a function. First is to solve for f of 4, which is 5. Second is to identify the limit of f of x as x approaches 4. The limit is 7. Then, the third part, f of 4 is not equal to the limit of f of x as x approaches 4. Therefore, we will arrive at the conclusion that f is discontinuous at x is equal to 4 and has a removable discontinuity. To make the function continuous, we will redefine and let f of 4 be equal to 7. And here is an example of a function with jump essential discontinuity. The given function is x squared minus 9 all over x minus 2. Is the function continuous at x is equal to 3? The first part is to solve for f of 3. If we substitute 3 to the given function, we will have the answer of 0 over 0, which does not exist. And the second part is to identify the limit of f of x as x approaches 3. Again, if we substitute 3 to the given function, we will arrive at 0 over 0. The rule is that if it is equal 0 over 0, the limit exists, but you need to simplify the given function to find the limit. So we factored x squared minus 9 and we will get the binomial x plus 3 times the binomial x minus 3. Then we will have the denominator of the binomial x minus 3. We will cancel out both x minus 3. That will leave us with the binomial x plus 3, and we will substitute 3 from the function, which will give us the limit of 6. Since one of the first two steps has an answer that does not exist, we don't need to continue to the last step and arrive at the conclusion that the function is discontinuous at x is equal to 3 and has an jump essential discontinuity. The last example is an infinite essential discontinuity. The given function is 3x plus 1 all over x minus 2. Is the function discontinuous at x is equal to 2? The first part is to solve for f of 2, which does not exist. The second part is to identify the limit of f of x as x approaches 2. The limit also does not exist. Since both the answers on the first two steps do not exist, we can arrive at the conclusion that the function is discontinuous at x is equal to 2 and it has infinite essential discontinuity. Here's a quiz to check your understanding of the topic. You can pause the video while answering and return if you want to check your answers. Here are the answers to the quiz. Today you've learned about three types of discontinuity, namely removable, jump, and infinite. A function is said to have removable discontinuity if f of c and the limit of f of x as x approaches c exist but are not equal. A function is said to have jump discontinuity if f of c exists and the limit of f of x as x approaches c does not exist, or vice versa. A function is said to have infinite discontinuity if f of c and the limit of f of x as x approaches c both do not exist. That's it. I hope you learned something. That's the buzzer. I'm out.